I do.
We do.
Oh, wow. Okay. I was going to be twisting some arms. Thank you. Much appreciated.
Okay. I think we have a pretty good
Okay.
form.
We have all of our presenters.
Thanks.
You got the
As well.
Okay, great. Let's get going.
Okay, welcome everyone to IPPM's meeting at IETF 119. Good to see people both here and online. All right, I'm Tommy Polly and this is Marcus. All right, so this is near the beginning of the week. So please, if you haven't already seen the note well, or if you want to refresh yourself, please do take a look at this. This is the terms under which we participate in the IETF. Make sure you're familiar with the requirements for what we need to disclose. And also, as a reminder, this is an area where we want to have productive discussions. And I think this group is very good at that. And so we appreciate your kindness and consideration towards everyone in this group as we try to work on and build good standards. All right. So here are just some of the logistics. If you're on Meetup remotely, you're already on here. So thank you for doing that. For everyone who is in the room, please do scan the QR code or join the MeetEcho onsite tool some other way. And this is also how we do the queuing to make comments at the mic. If you are presenting, we can share your slides from MeetEcho here as the chairs, or you can also ask to share slides from your own device. Either is fine. We do have a note taker. Thank you very much, Stuart, for doing that. And we can have people watch the chat. Okay. Great. So here is our agenda today. The first chunk is looking at a number of our adopted documents that we've had for some of them are new, some of them have been around for a little while. We're going to go through updates on all of these. Next. We also have 3 documents that have received a lot of discussion on list that we're going to have some deep dives into. These are things that we may be considering for adoption soon. So we appreciate your discussion there. And then finally, as normal, we will have some lightning talks. And these are expected to be just a single slide for a topic where people can introduce new work and highlight that to the group. Any agenda bashing before we go on? Okay, thank you. Also, actually, one more administrative thing I'd like to note. We should have put this on a slide. But previously, when you've been at IPPM, you've been in the transport area. You are no longer in the transport area. We have been airlifted out. Thank you to Martin for having guided us as a transport AD thus far, but now we are over in ops. So doesn't change too much other than how what area director is going to help us shepherd things. But we actually think this makes a lot of sense. This is very much related to a lot of other work that goes on in ops, and hopefully we'll have more cross collaboration there. So yeah, cool. All right. Oh, Greg, do you want to please comment?
Hi, I'm Greg Mirsky Erickson. Yes, actually, I do think that joining in ops area makes a lot of sense, particularly due to some discussion that was yesterday in ops area working group on characterization of different OEM methods, because this group published RFC 7799, and so the new proposal somewhat proposes to modify that. So I think that will be good now, since we're in ops area, and it will make sense that this group will discuss OEM terminology. Thank you.
Great. That's awesome. Yeah. So before we jump into the main part of the agenda, we did get a single slide update on one of our adopted documents. So this is from Rudiger, and both he and Len were not able to attend. All right, thank you. Neither of them were able to attend IETF this time around, but they just wanted to provide an update to the working group on the capacity protocol document. So there is a update to the draft, which is 07, that was addressing the sector comments. So I think they would like to see some more reviews from the working group on the list about that. So, there's a summary here. You can read that. This is posted on Data Tracker for the slides. But just to everyone here and online, if you have reviewed this before, please do take another look, take a review of that document, and we would like to be progressing this pretty soon. Okay, let's jump right in then. So first, I think we have Nalini. Oh, awesome. Understood.
If I make it that far.
Hi, I'm Nalini Elkins, and I'm Mike Hacken. We're going to give a quick update on PDM V2. So we got some input on the list. Thank you. We made the revisions, and we resubmitted the draft, and now we're looking for further marching orders from the chairs and from the working group. I'll try to field any questions that you all may have as well. Is that brief enough? Is anybody awake yet? The chairs have any questions? I'm dying up here, guys.
No, it's great that you revised the draft, and I think we can, we would definitely be able to raise it for another last call, or we can discuss if we even need to do that. But yeah, thanks for that update.
Okay, that's it then. Thank you.
I guess, sorry, while you're here, just to give you more to talk about. As far as like implementation status interop updates based on the updates in the document, anything there that's worth mentioning and sharing?
I'm going to say not anything terribly new there since the last meeting.
I'm not getting into the queue. I can help. We have implementation. We're thinking about a hackathon at next one, because that's where actually I need to go up to IPPM because that's the implementation. Right. There's some issues about doing cryptographic operations in IPPM. And so that's probably one of the things we'll do at the hackathon next time. But we're actively working. Would love to get some interoperable. Well, yeah, because if we can do it if we can do Windows, well, that's 2 implementations.
We do have some presentations in other working groups. The subject material probably is not terribly germane here, but it's more about extension headers than PDM itself, but we're using PDM to test, but not PDM V2. So again, not a tremendous amount of change since the last working group meeting here.
Okay, sounds good. So I guess for people who couldn't hear, not being on the mic, sounds like there will be hackathon efforts next time around in Vancouver for the BPF implementation, et cetera. But in the meantime, we can progress the document, and any learnings you get from that hopefully can be folded in along with updates when we get it to the ISG.
Absolutely will.
Thank you.
Thank you.
All right. Hey, everyone. Can you hear me?
Yes.
I am still awake. So, yeah, I'll present an update on our quality of outcome draft. Next slide, please. So this is the agenda. I'll go through the ID changes since last meeting. Brief note on the implementation status and ongoing projects, and then we have a few points for discussion in the end. Next slide, please. All right. So thank you to everyone who commented on the mailing list. We had quite a lot of comments. The biggest change to the document since last time is to add most of the contents of the other ID that we presented at the last meeting, the application quality metrics requirements as motivation and background to this draft. That goes through what we are trying to achieve with the quality outcome, and then also goes through a set of different quality metrics and sort of evaluate all of those from the perspective of the requirements that we set out, and then that sort of forms a nice background, I think, for the quality outcome draft. So I think at least, or I know that several of the people who commented on the quality of outcome draft actually also read this draft, because they were sort of bundled together. So I think doing it as a single document makes sense. And then we've addressed many comments. Yeah, noted a few of them here. There are still some outstanding ones, so please go to the next slide. Yes, so we have a few sort of stylistic things, like not using we as much. This one I get it, or I get the rationale for this. I'm not sure how strict the stylistic requirements are, but like I'm happy to do that if it's necessary. I found that we have quite a lot of places where we use we, so I didn't start sort of rewriting all of those sentences right away. But if you insist, I will make those changes. Then there are a few clarifications, like clarifying the latency can be measured in different ways. It doesn't have to be this TR452 from the Bruin forum, although that is our preferred way of doing it. We had a comment that we should add an example of the passive measurement methods, and add some additional information about whether, because we list some measurement parameters and then say that those ensure that network measurements can be analyzed for precision and confidence. And I agree that that should be expanded a bit. So all of these comments we have not yet addressed. And the two that I've bolded out here are the ones that I think are maybe the most sort of substantial things that we need to address, which is that the throughput aspect of measurements and requirements needs more work, because we mention it a few times, but we don't really specify the details of how that will work or should work. I have some sort of thoughts on it, but I haven't formulated that in the text yet. And then improving the section on how to create a network requirement. So several commenters pointed out that this would be a valuable addition, and I totally agree about that. So yes, next slide, please. Okay, so these are some of the ongoing projects that we have now with related to this quality of outcome metric. So we are working on defining some network requirements with an application provider, with Meta. We're working with Cable Labs on exposing some root cause analysis APIs that are based on quality of outcome. Then we are exploring sort of doing an open source implementation of this in collaboration with MLab and Will Hawkins and Predictable Network Solutions. So I think you all know MLab. Will has been involved in responsiveness draft, and then Predictable Network Solutions is the company behind the quality attenuation standard, or TR452, or QED from the Broadband Forum. Um, and the reason I'm mentioning these are just to sort of show that what work is ongoing, and to also hopefully, if there are anyone in the room who would be interested in working on one of these with us or doing something similar, we would be very interested to hear from you. So please reach out if you want to collaborate. Yeah, we are also measuring the impact of some. So with Wi-Fi 6, the Wi-Fi access point now has a bit more control over the scheduling of the Wi-Fi networks, and we are measuring the impact of those kinds of features using this metric with an ISP partner, and then measuring. We will also be measuring quality outcome from CPEs and other network equipment with another ISP partner. So that's what we are up to, or have been up to lately. Next slide, please. Okay, so this is a suggestion. We have found that, or we are sort of suspecting, I think, that the way that we have suggested dealing with packet loss in the draft may be a little bit too coarse in a sense, because essentially the application requirements has to specify a list of percentiles, and then like a perfect and a useless or unusable for each of those percentiles. And so let's say you specify latency numbers for the 99th percentile, and then you have more than 1% packet loss. Then your quality outcome would immediately drop to 0, because the latency distribution goes beyond the sort of point of unusability for that percentile. That could make sense for some applications, but I think it's likely to be not the best way of dealing with it. So what we are suggesting is to look at packet loss in a slightly different way, where in addition to the latency percentiles, you could specify a sort of, if you look at the bottom right corner of the slide here, a network requirement packet loss number for perfection and unusability, and then we can do the same sort of interpolation between these, so that the packet loss also gradually adds or decreases your score, right? This, I mean, we've started testing this, not conclusive yet, but it's, I think for some cases it makes sense, because I mean, some applications will deal quite gracefully with some packet loss, but then there comes a point where it starts to impact the quality. So doing it in this way allows to sort of model that kind of gradual degradation. And so feedback on this approach would be interesting. If anyone's has experience with how packet loss impacts applications or otherwise, that would be interesting. Okay, next slide, please.
I actually on this, I just had a quick question.
Okay, shoot.
Looks like Martin's in queue too. So, and maybe this is just an artifact of how I'm looking at the slide with the graph here for packet loss, but is the scale of perfect lack of packet loss to unusable packet loss, is that linear, or do we also need to express a difference there? Because you imagine like there are inflection points, at least in my experience, of up to a certain level of packet loss, you recover well, and then you start recovering a lot more poorly. And
Yeah.
I often find it's not linear. So do we have a way to express that? Or is that a really complex application requirement now?
So yes and no. You can express some nonlinearity in or some inflection points by deciding where the endpoints are, right? But between the endpoints, we're imagining just as a straight line for now. But I don't think that is. I mean, if we find that it's necessary to do a to make a more complex model, I mean, it's certainly possible to do that. What we and I mean, we have the same issue with the latency percentiles, right? Where it's also just a linear interpolation between the endpoints. And I think there is a sort of simplicity versus precision trade-off here. But yes, we could make that more complex if needed.
So I guess just to understand, like the suggestion is like, if I don't need to set my perfection to be 0, I could say my perfection is 0.5 if really anything up to 0.5 is fine with me.
Yeah, exactly.
Martin Duke, Google. I mean, I haven't worked with your analytical framework at all, so I can't tell you what's easier, but I think certainly you can model packet loss as latency. I mean, certainly if it's a reliable protocol, packet loss is latency for the application. Even in like a more UDP case, like it could be infinite latency. So if you find that to be conceptually convenient, like you can proceed with it. But there's certainly no problem with saying that certain applications have a threshold for packet loss. And that's certainly a much more intuitive way to look at kind of a media application.
Yeah, thanks.
Hi, I'm Eduardo from Exclusive Networks. So my question is regarding latency. That's a very good observation that, high latency leads to packet loss, but different apps behave differently, right? So based on your observation, have you taken into consideration the different kind of apps? Maybe a voice app will behave because it has different latency requirement versus let's say Facebook app will have a different requirements. But if you say that high latency leads to packet loss, that's a very general statement because there are different apps and there's different requirements.
Yes, thank you. So the way to model the requirements of different apps is to set these percentile thresholds at different points. So if an application has a sort of it can function well with even like moderate amounts of latency, then you can express that as sort of setting these points of perfection further to the right, if you will, on this graph. And if it's a very latency sensitive application, you can slide them to the left, right? And you can also, because the framework is very general, so you can add latency requirements for different percentiles. You can say, if for something that's very sensitive to latency spikes, you can add a requirement to a very high percentile in the distribution to express that this application will easily be affected by even short bursts of latency.
So this will be part of the draft as well?
Yes, yeah. I think it's that should be explained. Yeah, thank you. Okay, I see we're out of time, but that's good because this is the last slide. So if anyone has ideas about this or would like to work with us on finding better ways to express network requirements and comparing them to network measurements, please reach out.
Please.
Yep. Bjorn, this is Luis from Telefonica. I have a comment or a thought, let's say, about the notion of network requirement. So I think that somehow this can be dual in the sense that probably can be also seen as a kind of application requirement in the sense that applications are adaptive as well. So somehow what you are assessing there are the network conditions and probably from the application, something can be done in order to adapt to that conditions. So my comment is that probably it's more exact to comment about service requirements or network conditions rather than network requirement, because somehow put the attention on that the only thing that can be done is on the network, but probably something else can be done as well on the application. And there are adaptive applications, so probably could be more exact to refer to server requirements or network conditions. That's my comment. Thank you.
Yeah, that's a very good point, and I think that sort of if the application is very good at covering up sort of network degradation, then you can actually set a less strict requirements on the network and say, like, even if the network has some latency spikes or some jitter or something like that, the application will still work reasonably well. And for sure, some applications are better than that than others. So it's a good point. Thanks.
All right. So I think next up we have Altmark deployment.
Good morning. This is an update about this draft that has been adopted after the meeting of Prague. Yeah, this is a collaboration with several operators, so Swisscom, Telecom Italia, and China Mobile, about the deployment of the alternate marking methodology. So next slide. Yeah, again, what is the motivation? So we aims to provide guidance for the deployment of RFC 9341 and 9342. Especially with regard to the aspects of manageability, so the configuration and the data export. The scope is to clarify what is the deployment domain, what are the measurement nodes, the type of measurement that can be done, and under which conditions that kind of measurements can be done, and then cover the configuration, the data export, collection, and calculation aspects, and give other guidelines for the implementation, as well as security consideration that as the same included also in the base RFCs. Next. Yeah, just a recap about what are the measurement nodes, what is the deployment domain. So again, the deployment domain is a controlled domain. Especially we are talking about an overlay network domain where the traffic is encapsulated at one border, the encapsulator at the other border, and the encapsulation incorporates the relevant alternate marking data fields. In general, the marking nodes and the unmarking nodes border the controlled domain, but they can also be inside the controlled domain. So it depends on what are the section of the network we aims to measure. And of course, there are also the transit nodes that can do intermediate measurement in the middle. The type of measurements depends on the number of flags that we want to use, one flag or two flags. In case of one flag, we can do packet loss or delay measurement according to single marking methods. With two flags, we can do packet loss or delay measurement with double marking. Also, the use of one flag and two flags also affects the kind of the information and the computational load, because the two methodologies have different computational loads. This kind of consideration are also included. The duration of the period also affect the kind of information that we can get, as well as the computational load. And this imply also, let's say, change also the frequency of the measurement that we can do. Next slide. Yeah, let's say the gap that we want to cover, the main gap that we want to cover with this draft is to cover all the configuration data export aspect that were not covered in the base RFC's documents. So in this regard, this draft aims to highlight what are the requirements for the configuration and data export, and there are companion documents that are dealing with the specific Young model. In particular, there is the Young model that has been proposed also as a merge of two separate existing Young model for the alternate marking. So we also have a lightning talk on that later. So I don't want to explain this now. So there are also other control plane mechanisms to advertise and activate the alternate marking capability by using BGP extension, PSAP extension. For data export, we can use Young push, or we can also use the IPFix information elements. And in this regard, we also have an extension of the IPFix information elements. We place this draft in OPSAVG because normally the IPFix, let's say, experts are in OPSAVG, but we feel that this can be done, let's say, in parallel in two groups. Regarding the encapsulation, the draft also mentioned the existing extensions. Some of that are already RFC, other are adopted documents or ongoing. Security aspect, again, is the fundamental requirement of limited domain. Next slide, I think is the last one. Yeah. Regarding the next step, we want to make this draft stable. So we already had some discussion with the operators that are also cooperating with and are also co-authoring this draft. So the question is, we need anything else to clarify to make this draft stable, and we also want to move forward in parallel the other companion documents on the IPFix information elements and Young data model. So yeah, comments are welcome. Thank you.
All right, any comments, questions? Have people read the document? Cool. Thank you. All right.
Okay.
Okay, Justin. This has been an easy document, right?
Hi, everyone. So this is an update on the integrity of IOM. Next slide, please. We are still at 07. Basically, this is the one we presented in last IETF. And we are working on a next version. We received the third-year review, which is very appreciated. It was a nice piece of a review, and it helped a lot. But we still have a challenge. So designing this solution involves a lot of compromises. And there are several possibilities. I will cover them up so that you know, you have the big picture and you see, the entire process we went through. And so we are looking for some feedback from the working group. Next slide. Just a summary of the review from the security. Basically, some of the discuss points we had were easily solved by some edit changes. So most of them are already solved in our local queue. So we're going to send a new version in a few weeks after this meeting. But we still have one pending issue. And you will see in the next slide that it depends on the choice on the choice we make. So basically, this is about the header field selection. So you probably want to have the header included in IOM integrity protection 2, but you have to choose which field should go in, and it's not that easy, as we will see. Next slide, please. Just a reminder before going deeper. This is actually the structure we use for the integrity protection. And you see that some fields have been rewritten in red. So just to address a comment from Ben based on the review, which was that we should not refer as this method as to a signature, because this is not really a signature we are using here. We are just using a GMAC, which is basically a mode of GCM, so just like a hash MAC, right? So we renamed it to ICV, which is quite consistent with existing solution like ESP with or AH in IPsec. Next slide, please. All right, let's get into it. So the first option, let's call it 1A. We want a validation at the end, and we have header check included. So basically the first node, the NCAP node, would just GMAC the header. And by the header, I mean some fields of the header. So basically you want to exclude mutable fields. And you also GMAC your data fields as the NCAP node. And this is actually the same principle for the other nodes, except that a transit node would include in the GMAC the previous ICV, so that you have a kind of a chain of the ICVs to prove that you have the whole chain right. And each transit node can choose to check the header or not. So yeah, by the way, I'm focusing on trace option types here because other option types are working well with any option here. So this is the special beast here, the trace option. It's a little bit more complicated. And we want a solution for all option types to work the same. So we are going to focus here on trace option types. So this solution is the one that is currently in the draft. And you can read in the draft that if a transit node processes a field or a flag triggering actions from the node, then the node must check the header. So basically, this is the case with the DEX option type, because on each hop, it triggers the export of IOM data, and this is quite similar with trace option types with the loopback flag, because on each hop you would have to loop back the packet to the source. But the problem here is that if you want a transit node to check the header, it means that it has to recompute the whole chain from the first node, the NCAP node, up to itself, because you have a chaining of ICVs here, which is not efficient at all, right? And here, obviously, you would have each IOM nodes to require all the previous nodes keys too. And by the way, the pending discuss is not solved with this technique, so probably not what we want here. Next slide, please.
Greg, do you want to make a comment to this slide, or?
Greg Mirsky, Ericsson. So can you clarify, you mentioned that if direct export is other IAM trace option, then it automatically generates a packet with their statistics. That's the case that you address here?
No, I mean, so when I refer to field or flags triggering actions, I took DEX as an example because, as you know, each hop on the path would, based on the DEX header, would need to export the data, right?
No.
Why not?
Because RFC does not require that.
But if they do not, what's the point of the DEX then?
It's local policy. Basically,
right.
you can generate, you can send packets through the management plane or through any other means by aggregating statistically processing locally their raw statistics and operational state that being collected based on trigger packet. So that's DEX is very different from trace loopback. Yes, trace loopback as defined now automatically requires sending packet back, but DEX does not. It's not in RFC. It's one of the options, yes, but it's not required.
All right, my bad. So I should not have taken DEX as an example here. But
yeah, so probably it will be good if DEX somehow excluded from this processing.
I'm gonna cover that later. Yeah.
Thank you.
Thank you. Yep. So basically, if you want to improve the first option 1A, the only possibility we have to not recompute the whole chain each time you want to check the header is to obviously add an ICV to the packet. So basically, we don't have much room available in IPv6 option, so it's not maybe that good. But anyway, if you do that, you are now able to have the NCAP node generating the ICV for the header and then the ICV for its data field, and the same for, again, each transit node. So as mentioned here, the encapsulating node would have to perform 2 GMAX, which is, again, probably not that efficient and not that what you want. And again, still, each transit node will need the ANCAP key, okay, to verify the header each time. And the pending discuss point still unsolved in this case. So if you go to next slide, we want to avoid that GMAC 2 times on the NCAP node. We could, for instance, just change a bit the semantics of the ICVs, and instead of having the an ICV for the header and ICV for the data fields, have an ICV for the ANCAP, an ICV for the transit nodes. So in that case, that would work, but still have a drawback, which is that transit nodes would have to require to fetch IOM data fields from the ANCAP node just to check the header, which again is not semantically that correct. So, and this is even worse if you have the opaque state snapshot included in the trace, because in that case, you cannot rely anymore on the node length. So instead of using the usual bottom-up parsing of the trace, you would have to go top from bottom and then go back. And still the same problems as previous. So next slide, please. So just to say that the common problem between those 3 possibilities are that you have to check the header. So if we do that, it means that we have to somehow trust IOM nodes. Initially, we wanted to provide a solution where you don't have to trust any nodes. All right. So basically here, the only alternative solution is to avoid the checking of the header. And if you think about it, if we go back to the original focus of the draft, it was to just have IOM protection of the data fields, not necessarily the header. But I agree that the header is important in some case. But here we need to distinguish 2 types of fields in the header. There are fields that are required for the processing, and there are fields that are useful and provide context to the IOM data fields. And this is the latter that we need to be involved actually in the integrity protection, not the former. So just an example of such field would be the namespace ID, which is a common field between all IOM option types. And maybe we would need 1 more field, which is option type specific. So for instance, for the trace option type, we would have the trace type included as well. For the proof of transit, we would have the proof of transit type, and for the H2H, the H2H type. So I think it would be consistent, and we don't need any other fields. So let's review actually this solution on the next slide.
Greg, did you want to go first with your question?
Sorry to interrupt. Greg Mirsky again. So if we can go 1 slide back, because one thing that, again, what I wanted to stress and encourage authors of this work to distinguish is different behaviors of IAM trace options. Because when we have proof of concept or incremental pre-allocated compared to direct expert, so direct expert does not put any data in a trigger packet,
True.
Right? So the impact and security ramifications seem to be different.
Yeah.
At the same time, so as we discussed earlier, so their actions with their loopback flag, reaction to the loopback flag is different compared to the direct expert. So it seems that with the direct expert might be the lightest version and the most secure in a way, because it does not affect directly their data packet, nor it generates immediate necessary responses. So that might be interesting. One of the conclusions to mention in this document, saying that direct export has puts forward lighter security requirements comparing to other options. The other note that I want to share is that proof of concept mode, trace mode for IAM was primarily developed by service function chaining group. But as I know that this draft was is not advancing, and since SFC officially went into sunset, so the question of how important and how requested work on addressing concerns with the proof of concept, something to be clarified. So it might be interesting, but not really requested by anybody.
Thank you. Yeah, but back to option 2. So basically, this is the one that would improve the alternative to option 1, A, B, and C. So here you have, obviously a faster processing on transit nodes, because now you don't have to check the header. The header actually, at least part of the header, so the namespace ID and one specific field, depending on the option types, would be checked on the validator at the end. And so now the ICAP node would just, include 2 fields in the GMAC, 2 fields from the header and its IOM data fields. And you still have the usual, chaining of ICVs, etc. on the transit nodes. This one actually matches what we wanted at the beginning, which is don't trust any node. This is probably the best solution, even though this is maybe not that elegant on the DCAP node, because it has to, check all the chain, which means n GMAX, depending on the number of nodes. But here, again, the pending discuss is solved in that case, because you don't actually freeze the structure of the header, because you only need 2 fields, and this is going to be consistent with any new future option types anyway. So it's quite acceptable in that case. Next slide, please. So yeah, we're going to see 2 other alternatives. This one is actually a proposal from Ben in its review. Let's call it neighbor validation. So in that case, it's a peer-to-peer validation. This one is quite easy. So basically, a node would just GMAC the entire trace, so the entire header and the entire pre-allocated block. Now you can include even mutable fields from the header, because it doesn't change from peer to peer, right? So you just include the whole block, and your peer will validate, and then it's going to be the same process to the next peer, etc. But again, here you have to trust some nodes, because you have to have some key distributed somehow. So we are not anymore in the don't trust any nodes context. So it's a lightweight solution, because you share a little bit the load of the validation of the chain, but you have to trust some nodes. So that's the drawback here. And again, the pending discuss here is solved as well, because you can include whatever fields from the header you want without any problem. Next slide, please. Very similar to option 3 is to use actually IPsec. The advantage is that it already exists, so you don't have to specify another protocol for that. The drawback is maybe that you have to configure IPsec tunnels everywhere, right? Yeah, you can love. So basically here, it wouldn't be only between IOM nodes. It would be between all your nodes, because you cannot really predict what's going to be your endpoint of the tunnel with IOM, because of a lot of reasons, right? And again, those are the same problems than option 3. Next slide, please. So let me summarize this a little bit. Next slide, please. If we want the protection of IOM data fields, and we focus on that as the main goal, we probably, as mentioned earlier, we probably want, a full protection. And by full protection, I mean, you don't trust any nodes, so you don't have to share keys in between nodes, etc. So the only one that matches that is the option 2. Next slide, please. Now, if you want to have something lighter, then you could go with either option 3 or 4. You can see in the metrics that they are very similar. So we selected option 4 just because we are lazy and it's an existing solutions. But again, option 3 is probably equivalent and maybe it's going to be a little bit efficient. So if the working group feels like we should cover option 3 as well in the draft, just speak up. Next slide, please. Right, so let me conclude on this one. What is the proposal of the authors? Well, we think that it's better probably to go with option 2 as the main solution in the draft. And we think that we should probably cover, IPsec deployments. So the option 4 in the draft as an alternative for people that wouldn't go with the first option. But again, if you think that we should cover option 3 as well, maybe, or whatever, just speak up, and we're just waiting for some feedback from the working group, even the shares.
Cool. I got in queue just to have a comment, but I'd love to see feedback from everyone else, so please do that. So first, thank you for doing the analysis here.
It was a journey, actually.
Yes,
so.
exactly. Yes, I can tell. So appreciate that work. So I mean, overall, I think your proposal here is it feels right.
Yeah.
I agree that option 2 makes the most sense here. With regards to the IPsec option, even if we're mentioning it, I don't have a great sense of this. Like, to what degree does using IPsec between these nodes also change like the nature of what's being measured? Like, are you putting all of the other traffic through this now? Like, because normally, I'm assuming with IOM you are kind of using the same network path, and now having this go over some IPsec overlay is potentially a very different layer.
Yeah, that's the problem that can happen. So
okay,
could be an argument to have also option 3. I don't know.
I would lean towards simplicity, and you can always add security considerations, say like this threat exists, and just describe it and describe what would be required to overcome it, but say that this document doesn't solve it.
Yeah.
That is a thing we lean on often, and I don't think we should be afraid to do that here. The only other question I had is from an implementation standpoint, because ultimately this only matters at all if someone does it and if it's practical to do.
Yeah,
So,
I forgot to mention, actually, I spent some time a few weeks ago to implement it in the kernel. I implemented option 2 and 3. So I'm about to collect some results from the measurements. But from an implementation point of view, it was okay. Just to say that option 2 is a little bit more complicated from a code point of view, which
because
is
it has
expected.
more layers.
Yeah.
But it is doable. So
It is, yeah,
okay.
Sure.
So you think that if we go with option 2, somebody would actually use it?
We hope so. At least we will discuss some mitigations, in the draft to spread the load from the validator, because obviously if you have, let's say 10 or 15 nodes in the trace, it's going to be huge for a single node to validate the trace. So
okay. All right. Sounds good then. Other questions people have or other thoughts? Any opinions? Do we want to do like a show of hands type thing to just say like, yes, the people in this room agree with this? Would that be useful?
why not? Yeah.
What are the options we want to put on here? Just like, are we fine doing option 2?
Yeah, we were expecting, that people would agree with the proposal, but anyway, just ask in case.
So I'm going to say, do you agree to move ahead with only option 2?
And maybe mention,
Right, for...
So you would go with the no mention of IPsec at all?
I mean, I'm curious if people would be okay with doing option 2 and then just describing
Yeah.
the security implications,
All right.
but not having to design option 4 for
Right.
people.
So I'll pack that for inside the next version.
Yeah. Okay, let's try the show of hands thing. So if you haven't joined Midako yet, you should do it now.
First question should have been who read the draft.
Well, but also, I mean, even if you haven't, if you're listening to this conversation, a lot of apathy, no opinion. But we have some people saying yes.
Yeah, for the no, could you maybe speak up to explain why? If it's in the room or...
Yes, please.
Paolo, I was the one supporting no, just to have more flexibility. That's it.
So what would you like to see? Would you like to see multiple options?
Yes, please.
So option
Could-
2,
could
3,
be-
and discuss option
yeah.
4 too?
Could be a possibility. Just
Yeah.
my opinion.
Is it necessary to be in the same draft, or if you have this problem, would it solve it if you have a separate draft?
Not
solving it?
necessarily.
We can do that in a separate draft because we have a registry, so it could be added later.
Okay, yeah. All right. So we have, mild support. For a lot of people, no opinion. But I think at that point,
Yeah.
it's up to the author's
safe to go that
discretion.
way,
I
yeah.
think this seems like you're going in the right direction. Let's just push this out and try to go through the last call.
Yeah.
Okay. Thank you.
Thank you.
All right, we now move on to our non-adopted documents, starting with stamp.
Hi everyone, my name is Rakesh Kadi. Tommy, you hear me?
We hear you.
Ah, perfect. So I'm presenting a draft stamp extension for reflecting the stamp packet headers on behalf of the authors. Next slide, please. So agenda is to look at the requirements and scope of the draft, the summary of the stamp extensions, and the next steps. Next slide, please. So basically, stamp there are extension headers for IPv6 and MPLS, and stamp carry those extension headers and like to reflect them back. The use cases would be hop by hop measurement, and also we want to control the headers on the return path of the stamp. So goal is to, you want to leverage the existing midpoint nodes so they are not aware of special processing. We're trying to avoid any IPv6 and MPLS protocol extensions. And this is the scope is stamp and stamp extensions for IPv6 options and MPLS network substacks that's already defined. And next slide, please. So here is a simple example where in case of IPv6 data plane, stamp is carrying multiple IPv6 options. So stamp would have pre-allocated empty TLVs as the stamp TLVs, and then on the reflector side, basically the receive options are copied into those empty stamp TLVs and send them back to the sender. So for example, if you collected IOM, hop by hop data, this is the way you would reflector would send it back to the sender. So it's like becomes an active measurement, but M1 midpoint node has no knowledge about this stamp, for example. So this is optional behavior. maybe you don't want to do the measurement in the reverse direction, and then you don't want to put the extension headers there as well. So there is some extra work for that. And next slide, please. So it works the same way for the MPLS data plane. There is a working group document for MPLS extension headers through MNA, MPLS network action, and idea is the same. So the packet carries the MNA. Stamp would have empty TLVs to bring the data back from reflector to the sender. So the same idea as IPv6. And next slide, please. So there is one additional requirement that we want to do measurement in the forward direction, but not in the reverse direction. Maybe we don't want to do direct export in the reverse direction or collect data in the reverse direction. So there is work, the draft Musky defined asymmetric packets. So we would leverage the TLV that's defined for the reflected packet control TLV and add a new sub TLV extension header control. And when it's set, then basically reverse direction stamp would not carry any extension headers. Next slide, please. So it's basically a couple of stamp TLVs to be defined to reflect the IPv6 or MNA extension headers back, and one sub TLV for the asymmetric packet case for draft Musky. Next slide, please. Since we are talking about stamp, there is some work going on for encapsulating stamp in other working groups. In Spring, we have a segment routing encapsulation, and in MPLS working group, there is a pseudo-wire or MPLS encapsulation for stamp. So welcome your comments and a review on those stamp drafts as well. And next slide, please. So thank you, Greg, Shomin, for your review comments. Quite useful. Welcome additional comments and suggestions. It's a fairly simple, straightforward draft for stamp extension. It's quite useful. And the idea is to request the working group adoption for this draft. Thank you. Any questions, comments?
All right, looks like we do have some folks in queue. Shaman?
Okay, Rakesh, Xiaoming from ZTE. Thank you for taking my suggestion into consideration. Even if you didn't take my advice to use one stamp TLV, that's fine to me. That's acceptable to me. But I have another suggestion. Would you mind to consider add a new stamp TLV to reflect the IPv6 header? So not just extension headers, but IPv6 header.
Okay. Yeah, looks like a good idea. Yeah, we can discuss it, and yeah, we could. I think it's possible to add that. Yes.
Okay. Thank you.
Thank you.
Hi, Rakesh. Giuseppe speaking. Yeah, thank you for working to this document. I support this work. You may remember during the last IETF, I also presented a similar hop by hop extension. I think we can further discuss how to integrate the two drafts and to see if it's possible, yeah, to come out with a single document so we can just replace the other document and go with one. Okay. Thank you.
Yeah, we can discuss that. Thank you.
Any other comments, thoughts on adopting the work, support, apathy? Maybe a quick just raise of hands in the room, at least if you've read this, followed it. Greg, yep. Okay. like 3 people in the room. It's pretty good. Cool. Okay.
Thank you.
Oh, Greg, did you have a comment on that last one, or?
No, just
Please go ahead.
I believe that comments were addressed, my comments in particular, and the draft is well written and in good shape for working group adoption. So it's, again, nothing is perfect, but it's a good level to get it adopted.
Great, thank you for that feedback. Yeah.
Yeah, thank you.
Certainly not going for perfection before we adopt. The point of adoption is that we can make things more perfect.
yes. Get in control.
Exactly. Okay, please.
All right. Hi again. So this one is not a new draft. It's been refreshed many times. This draft defines a way to export IOM data with IPFix. Next slide, please. So it's been, presented like 2 years ago, the last time, I think, in IPPM, and it's been also presented in AWG. And based on some recent interest on the mailing list, we thought that it might be interesting to refresh it one more time and just, touch a little bit the working group to have their opinion on that. But we probably think, we're not that objective, obviously, but we think that it might be good to have it adopted because we see more and more Yang models and IPFix export solutions for existing and not really new protocols. So we could just align on this one because right now we don't have, a real method to export IOM data. Next slide, please. So the question is first, do you, IPPM, want to adopt this draft? And if not, should we ask Ops AWG? Or should it go the other way? Should it be adopted by, Ops AWG and involve somehow IPPM at the end? I don't know. So I think this is something we probably need to discuss with you too. So.
First of all, thank you very much for that work. I think this is very valuable. I think we are really at the right stage right now that we need to define the exporting protocols as we are already doing that with alternate marking. And I think this is very valuable for a network operator. And I believe since we already have other IPFix related work for alternate marking, also on-pass delay, currently ongoing at Ops AWG. I would love to bring this work also in Ops AWG that we can look at all 3 documents there at the same time if possible. Thank you.
Thank you. So yeah, we discussed offline about this and I'm not against one way or the other because we already did that IPPM and then involve Ops AWG later in the cycle. We did that for previous drafts. So one way or the other, I think it's fine. So yeah.
Greg Mirsky Erickson. So I have a question. You in the document, all different IAM trace options, they are considered differently. So would they result in a different export, in different IPFix?
So I really gotta be honest here. It's been a while since I didn't read the draft, so I don't even remember. I'm actually not in the author from, I'm just a proxy today. So I think so, but I'm not very sure. So
Yeah, because if we look at this as exporting data collected by IOM, then probably that will, if we look at raw data, then each node produces particular record according to IAM header, regardless of IAM trace type. The only difference would be that, for example, in pre-allocated incremental, so when these records are collected in a trigger packet, they will be exported probably sequentially, could be sequentially, with a node identifier from their IAM decapsulating node. Whereas in, for example, direct export, that could be done by the transit node as an option, or actually another thing is that we can look at is exporting statistical processing result of this data from the transit node. But at the end, so my thought is that look for IPFix as exporting collected operational state and data regardless of the IAM trace mode.
So you want something more generic, right, for option types here?
Yes.
All
so
right.
regardless of option type.
Okay.
Okay. So that basically, either it's by individual node or by decapsulating node, but they export it in the same format that basically reflects request expressed in IAM header.
Okay, we'll need to discuss that
Yeah,
with the
but
authors.
we can discuss it.
Yeah.
I agree with you that it's a valid option to export using IPFix, and so with the trend that Thomas mentioned, it definitely would be used. But look at it that it's independent on trace mode.
Right.
Thank you.
So actually, that's good news because the purpose of the draft, you're fine with it. So we just have to work a little bit on the content. Yeah.
Thomas Graf, Swisscom. I just wanted to follow up on Greg's comments. So my take is basically currently the draft document is describing how to export IOM, the section, so basically the raw packet. And I would be interested to see that we can also decompose the IOM dimensions into IPFix so that, for instance, in the trace option type or the direct expulsion type, that we can do apply it for IPFix flow aggregation, and that would dramatically increase the scalability of this work.
Right.
Thanks.
Thank
you. Martin Duke, Google. I guess I don't understand the motivation for this work. So can you explain how this is different from direct export?
So I remember your questions. I
Did I ask this last time and I just forgotten? Okay, well then never mind. I'll just read them.
No, that's okay. So basically, this one is just so with DEX you would just include the header in the packet, and so each node would sometimes export data. So how you export the data, you don't know. And this draft is actually defining a way to export the data.
I see. Okay. Thanks.
I just want to follow up the comment from Thomas. So with alternate marking IPFix extension, we are doing the flow aggregation. So we just need to export counters, and I think we can try to reach the same way with the IOM.
Yeah, of course, yeah.
It's not raw data, but just have much more flow aggregation when we export as with the alternate marking. So
yeah, so
it is more
let's discuss
convenient.
this. Yeah, of course.
You can just export the relevant information.
Thank you.
Right, thank you. We can definitely discuss the right venue for this. Maybe the feeling is that if we are doing other IPFix export work in ops area, so maybe that makes sense to group it all there, but we can discuss with you.
All right, sir. Thank you.
We can take it to our new AD who is in ops.
Greg, I think you're next. Okay, next slide, please. Okay, hello. Greg Mirsky Erickson presenting on behalf of the authors of reflected packet control extension for STAMP. Next slide. And so as you see, Richard Footer joined us as an author. We welcome him. So we have some technical updates, editorial updates, and response to Rakesh comments clarifying their interworking with their STAMP extension for segment routing. It's being published as RFC 9503. Next slide, please. Okay, so on the technical, for interpacket, reflected interpacket interval, we clarified that the unit will be in nanosecond. In looking at this, so because it's a 32 bits unsigned integer, it seems that it's a future-proof granularity. At the same time, it will allow significant flexibility in determining longer intervals if somebody wants. Another question that we were discussing, and we are welcoming your feedback on the number of reflected packets. So should we look for some reasonable upper boundary for this field? Okay, so I'm posing this question, something for your comments on the mailing list. I'm not pressuring an answer now. Next slide, please. So we extended security consideration. And one of the things is that was added, as you can see here, it's a direct quote from the updated document, that their sender that uses reflected packet control TLV should not send the next test packet until all the expected reflected packets are expected to receive. So basically, multiply the number of requested reflected packets by the interval, then wait a little bit more, only then send your next test packet. So just any questions about this update? Does it make sense? I really hope so. Next slide, please. Okay, so there is an interesting part. So Rakesh pointed out that STAMP extension for segment routing allows control of creating a unidirectional testing, so that there is no reflection. And apparently, this proposed extension, reflected packet control TLV, also allows for creation of unidirectional texting by setting the number of reflected packet to 0. And since we want to have a flexibility of using both TLVs, both extensions, so what happens if both of them do the same, or if they are contradicting each other? For example, if there is a present of SR which mandates unidirectional, and there is this new TLV that has non-zero number of reflected packets. Okay, so we think that we can say that implementation that supports both extensions must not include return control code sub-TLV with a control code set to no reply requested, and non-zero reflected packets in reflected packet control TLV. So, but if somebody doesn't listen and will do that, then session reflector must set U flag in both TOVs in the reflected packet. So that's indicated that it doesn't understand you. And also, session reflector should send event notification or log notification controlled by throttling, rate limiting mechanism for logging. So reporting this situation. Any questions about how we proposing to handle this situation? Yes. Sorry, Mike.
Sorry. My question is regarding the rate limiting of the reflected packets.
Mm-hmm.
Can you reiterate on that? So
Yeah.
this is packets coming back from the.
Yes,
from
correct.
the
So
nodes,
yes,
right?
okay. So original motivation for this new extension was that rate measurement. So where there is in some environments there is a beneficial to be able to control asymmetrical flow of reflected packets, so that here we are setting profile on how many packets will be reflected and at what equal interval they will be generated by their session reflector. So that's original. But by looking at this mechanism, so we realize that, well, if we are not excluding a number of reflected packets being non-zero value and will allow zero, that effectively that creates a unidirectional measurement. Because effectively we are saying to the reflector, do not reflect a packet back. Right. And the same functionality is available through RFC 9503. That's what Rakesh pointed out. So naturally, we were faced in a situation if both TOVs are present in the same test packet, so how the session reflector must handle the situation when there is a contradiction. Because yes, if both TOVs say do not send packet back, okay, fine. So there is no controversy. But what we are trying to handle here in this update is, well, what happens if there is a controversy between two extensions?
Yeah, that makes sense.
Thank you. Okay, again, that's an open question and obviously for discussion. Next slide, please. So with that, it concludes all the updates so far. We welcome your comments, questions, suggestions, and we believe that draft is reasonably stable, that is ready for a working group adoption poll.
Any more comments from anyone? I can relay some comments from Björn, who decided to go to bed, but he wanted to send some proposals.
Good night, Björn.
So basically he says, I find the proposal interesting and support moving forward with it. I'm slightly concerned about the security aspect of allowing asymmetry in the number of packets. Since one packet can trigger many responses, there will be a risk of DDoS-type problems. Authentication and/or limits on the number of responses should be considered to mitigate, in my opinion. And I guess that's what you discussed.
Yeah, that's our sentiment of the authors, as we discussed. As I mentioned, that is there logic in limiting their upper boundary for the number of reflected packets, and even might be not allowing very frequent, so very small intervals between the packets. So definitely something that should be discussed further or addressed through mitigated through the appropriate security concerns. What I want to point out that in our first stamp option extensions document, so we do have HMAC TOV that can be used, so might be in the next update, we'll look for explaining how that should be combined. But effectively, there is already a mechanism in stamp extensions that can be used, I believe. Okay.
Rakesh?
Hey, thanks, Greg, for addressing the previous comment. If you can go back to 2 slides where there is a should not, yeah. I was just thinking about it. It should not do that, but what should it do? So if it is asked to send packets at the higher rate that it can handle, and I'm just thinking, should it send some U flag to saying that I cannot support this kind of rate and slow it down to sender, or should it do something about it?
Actually, good point, because okay, so it's not in this update, but I believe that's already in a document that session reflector, if it cannot sustain their requested rate of reflected packets, it will send back exactly with the U flag in reflected test packet control, saying basically that should be interpreted that I cannot sustain it.
Okay. Okay, that's perfect.
Yeah, but I agree. It's because there might be a situation where reflector cannot sustain the requested rate.
Okay. Yeah, thanks. And I support the work. It's quite good and quite useful. Many thanks.
Thank you. Okay. Thank you.
All right, we'll start with some lightning talks now, beginning with the multipath flag for IOM.
And again, just on time for these, we want to just have 1 slide of content and spend just a couple minutes introducing it briefly and why should people be interested.
Okay.
So.
Okay. Good morning, everyone. This is Li Zhang from Huawei. Our work is IOM multipath flag extension. Next slide, please. Yes, this is just a brief background. Yes, IOM collects OM information within the packets when the packet travels across a particular network domain. And RFC 9322 provides 3 kinds of active measurements with IOM using IOM and define an active flag to indicate that a packet is an active measurement packet. And the stamp extension header uses stamp to reflect any IPv6 options, including the IOM date fields. So, however, the existing active measurements are typically just for one specific path. It cannot collect other paths information when there are multiple paths to the destination. An example is shown in the figure, and there are 2 paths from node 2 to node 5, but if we perform active measurement on node 1, it can only get 1 path's information as the yellow one. Okay, that's. Yeah, so we define a new flag in the pre-collocated and incremental trace option header to indicate that this packet is for active measurement, and if this node have multiple paths to the destination, you should copy this packet to every path. So, and an example on how to use this flag with active measurement is shown in the figure. Firstly, the node 1 should generate an active measurement packet and with the multipath flag set up. And then the packet reaches node 2, and node 2 finds that there are 2 paths to node 5, and it will copy this packet to every path. And the following transit node does its own information to the packet. And finally, the node 5 will receive all the packets and report them to the controller. The controller will restore all the paths information. And similar, this extension can also be used with the stamp to collect all the path information. Okay, next slide. And yeah, we welcome for any comments and questions. Thank you.
Thomas Graf, Swisscom. If I understood correctly, you're proposing in this document to clone a packet based on an IOM flag.
Yeah.
And as a network operator, I like to raise my concern. A network telemetry protocol shall not be intrusive in the packet forwarding. So I believe the objective of this work should more going into the probing protocol itself or in the IP protocol. So for instance, in IPv6, we have the flow label, which is specified in RFC 6437 to influence the multipathing.
Okay, thank
you. Greg Mirsky, Ericsson. I concur with Thomas that flooding the network to explore concurrently all available paths might not be a practical approach. So using the entropy, whether it's a flow label or entropy label or FAT, pseudowire FAT label seems to be. So that's way you can ensure that first you can discover all the multiple paths by using tracing, and then use the same entropy values as your data for your measurements. So for IAM, that's not a problem because you are using data packets as your trigger, but you can use the same values, entropy values, for synthetic performance measurements, for example, using STAMP. So thus, you know that you are measuring the same path as being traversed by their data packets. So I don't think that replicating packets is useful, especially since, as you can see here in your diagram, you will be a challenge of merging these flows. And then you're either have to somehow merge the measurement information, or you need you will be producing redundant measurements, which is counterproductive and unnecessary burden on the network.
Yes.
So probably using entropy, it's more practical. Thank you.
Okay, thank you.
Okay, next up is Giuseppe.
Hello. Oh, hello. I'm Xiaomi from Telecom.
Yeah. There's the Yang model in between.
Okay.
Mixed up the order. Sorry. So
Giuseppe, no, isn't it Alt Mark Yang?
This is
That's
mine.
that's the right one.
Was it the right one? Okay.
Yeah.
This is the right one. Okay.
Yep.
I don't remember if I was first on.
Yeah, you're right. You're right.
Okay.
Go for it,
Okay.
Wait.
Okay.
Sorry, who? I can't see who's speaking.
Yeah, please go ahead, Giuseppe.
Giuseppe here.
Oh, this is not my draft. This is not the draft. Anton.
Oh my God. Too many slides here.
You change it again.
Sorry. Let's see.
It was the
Altmark.
Yeah, Altmark. Yeah. Oh yeah.
Yeah, as I mentioned in the past, in the previous my presentation, this is the Yang data model for the alternate marking draft. Next slide. This is the result of the merge of previous two existing alternate marking Yang models. I want to thank Xiaomin for helping me and to support this work and to work together to merge the two young models. Now we came out with a single tree structure. We agreed, in particular, the main result that we only have one young data model. We agree on the tree structure and the related information. Basically, we follow the same structure of the IOM young model for compatibility reason in order that to have the same similar information when is possible. We included 2 examples for IPv6 and MPLS. So yeah, we welcome comments about this new young data model, and we hope we can progress. That's all.
Okay. Any questions, comments? Okay.
Okay.
Now we're going to do integrating AM into IOAM. Jump to the next.
Okay. This chapter is about integrated watermark method in motive and objectives. And the watermark method has wanted employed in Oculus network to implement performance measurements such as packet loss, delay, and GTS. IOM, such as passport mode and postcard mode, have faced some problem challenges in the performance measurement, such as packet loss. This document intend to augment IOM's capability in performance measurement by including incorporating outlet market method. Next slide, please. Problem and challenges. This ones, the IOM-DX option could only work in SMP mode, that is subset of traffic, so the fidelity of the packet loss measurement cannot be ensured. It's true, the receiving entity needs more processor overhead to collect large amount of data for packet loss computations. It is risk the receiving entity needs to decide the measurement method. It is not beneficial to unify the measurement methodologies. Next slide, please. By integrating the outlet mark method into IOM, the benefits of obtained include one, IOM encapsulated load could cut all the traffic of interest it forwards, not a subset of the packets. Thus, the fidelity of the loss measurement can be ensured. Two, compared to IOM DX options, the receiving entity needs much less processing overhead to calculate block count values for packet loss computations. It mitigates the network and the receive entity greatly. Three, be able to implement performance measurement and IOM transmodally concurrently. Four, the receiving entity does not need to consider about how to make a measurement, but can only compute the result of each measurement period. It is beneficial to unify the measurement methodologies. Next slide, please.
All right. We do have some people in queue, and again, for these lightning talks, we do just want one brief slide overview and not go into too much detail. We just want to introduce it. So let's have Greg and Thomas come up, and then we'll move on from this.
Yes, Greg Mirsky Erickson. So I wonder about their motivation for this work, because as I understand, IAM and alternate marking methods, they are receiving consideration in data planes separately. So there's been standardized IAM encapsulation in IPv6 extension header, and I think that their work on alternate marking methods is proceeding nicely. And both of these methods in MPLS data plane, it seems to be resolved by MPLS network action work, resulting from that work. So it seems that they might be applied to packets independently. And I don't see that there is anything that precluding applying both methods concurrently on the same packet, if somebody desires. So I wonder what's missing. Thank you.
Thomas?
Yeah.
Thank you. Thank you. I'm thinking.
Go ahead.
Okay, I will discuss it by email. Okay.
Great.
Good.
Okay,
Thomas
Thomas.
Graf speaking. So I read the document, and section 3 describes problems and challenges and mentions excessive amount of exported data. And if I understood correctly, this work is targeting improvements in the IOM metering process. And I would appreciate in that very section where you're stating the problem, that you put the IPFix flow aggregation, which is defined in RFC 1715, whenever when IPFix flow aggregation is being applied, whether the problem statement still holds true or not. Thanks.
Thank you. Questions. Okay, we will discuss by email. Thank you. There's another chapter.
So let's try to be a bit more brief on this. So because this we have a lot of lightning talks to go through. So if you want to choose one slide to talk to, maybe that would be.
Okay. The waterlet mark method has been one employees networks to implement performance measurement. IOM trace of option as core passport mode has a lot low ability to monitor packet drop and packet drop locations. This document defined the IOM trace option extensions for incorporating the automarket to augment OM's performance measurement. Next slide, please. The extended trace option format use the most significant 5 bits of the received field, air bit for packet loss measurement, D bit for packet delay measurement, F bit for flow ID flags, S bit for SN flags, M bit for MPN flags. Next slide, please. Next slide, please.
Yeah, so maybe if you can wrap up very quickly. So we need to go on to the next.
Yes. The extended trace option should support to perform both performance measurement and IOM trace monitoring concurrently. For performance measurement, IOM encapsulate load must mark all the service traffic packets of interest for with EL and LD flag to extended track option type. For IOM trace monitoring, all the traffic of interest or only a subset of packet could be selected by OM in encapsulated load. Yes. Okay, that's all.
All right. Any questions, comments? Should we move on? All right. Thank you. Okay, so I think next we have the Customer Experience Index. With one slide. Yeah. Do we have someone going to be presenting this? Yeah, Hong Yi? Okay.
Okay.
Are you one of the co-authors?
Yeah, I'm next. I can cover this, but I'm the next.
Oh, you're the next.
Oh, you're the next one.
Let's switch order. Yeah.
Oh, I see.
Sure, let's do that.
Okay, that's fine.
So, yeah.
Perfect.
Also one slide. Fantastic.
Thank you.
Thank you. So this draft is about proposal to make the supporting IOAM in IPv6 more scalable. We all know the IOAM is good technology to allow us to monitor the on-pass network performance by collecting the data along the traffic forwarding paths. In the context of IPv6, IOM trace option need per hop processing, which means it must be held in IPv6 hop by hop extension header. And according to RFC 8200, IPv6 hop by hop extension header must be the first extension header. Unfortunately, there are other use cases like segment routing, which will apply routing header, which will be located behind the hop by hop header. And if we try to collect a large amount of data along the path, which will make the trees very large, so the first hop by hop extension header will be big, and which will make in some certain implementations very hard to access the later routing header. And that's why in the RFC 9486, it is proposed to support IOM pre-allocated trees in hop by hop extension header. If we use this solution, we have to limit the size, the amount of data we collect per node, and also the total hops we can support. So that's not scalable. And so as SRv6 becomes more prevalent, we do need to mitigate this problem. That's why in this draft, we propose several alternative solutions to make it more scalable. The first one is we can try to separate the IOM instruction part and the data trace part, and put the trace part, data part after the routing header. Because the instruction part is small, it has small overhead and fixed size. So it will not make the hop by hop header very large. And so that allow us to access the routing header easily. And then we use an incremental mode instead of the pre-allocated mode of IOM, which means we will always insert the new trace data at the fixed location. That's immediately after the routing header. So that's also very convenient. So the problem here is where we put this trace data. We have two proposals in this draft. One is we just make it a TLV option in the routing header. Another is we can develop a new type of extension header, just hold this variable data in it, so we can make this another TLV option in that new extension header. So this is the first proposal. The second one, we call that segment IOM export. The idea is simple. So according to, based on the hardware limit, we just fix the size of the supported trace data size, right? If we can, for example, if we can only support up to 5 hops data, then we just pre-allocate that amount of data in the hop by hop header. And once we reach that limit, so we force the data to be exported, then we clear the data fields, and which means in the next hop, you can start over again to collect the data for the next n hops. So by doing this, we can always keep the overhead small and fixed. And another equivalent alternative solution is if we use this with SRv6, which means at each segment endpoint node, we will need to access the routing header. But before we reach that, we may already collect a lot of trace data in the hop-by-hop header. So how we do that? Then we will force, and each segment endpoint node, we will force to export all the collect data so far. And then we clear that field, and now we can access the routing header. And then in the next IP router hop, we can start to accumulate the data again. So by doing this, we can also make it more scalable. But the issue here is actually we don't know how many IP hops actually between two segment endpoint nodes. If that path is very long, still we might meet some scalability issue. So, and in the draft, we also compare with another solutions. We can try to just reuse the IOM direct export mode described in RFC 9486. That's a postcard mode, but it's not like the trace mode. But we all know the postcard mode has its own issues. And so here we are talking if we just want to use a trace mode, so what we can do. So I think this draft gave a good summary of all the candidate solutions. And
right. So should we go to questions?
Yeah, please.
Thomas Graf, Swisscom. First of all, thank you very much for raising this point. I'm sharing your concern that on applicability of IOM trace option type in SRv6. I think this is valid work. However, I would like to hear from other network vendors whether this work or the proposed solution is applicable to their implementations.
Okay.
Thank you.
All right. Thank you.
Greg Mirsky, Ericsson. Again, I second Thomas, that thank you for your analysis and highlighting this issue of scalability and possible cost of using pre-allocated incremental. I personally look for the solutions as in the reverse order, because we already have direct export, and that seems to be readily available solution to all the problems. Thank you.
Yeah, as I said, it has its own problems, like the data correlation. So trace has its own merit. So yeah, if we
just sorry to running back and forth, but we do have already proposal. It's a hybrid two-step, which considers correlation by collecting all information following the same path as a trigger packet. So that simplifies. Also, as I'm aware of some proposals that simplify correlation on orchestrator or collector. Actually, if we look at the architecture of being the for the large-scale access networks, there was a used to be a group LMAP, and they worked on informational model for measurements in large-scale access networks. So where they designed that you have a collector which collects all the measurement results. So exporting data to collector could be done using different methods with characteristic information that simplifies correlation. So collecting in the same trigger packet, it's one of the ways. I acknowledge that, but there are other ways.
Yeah, those are all possible solutions.
Right.
We should
But
put all them on table.
I just wanted to point it out that we already have a solution for the scaling problem. Direct export. Thank you.
Thomas Graf, Swisscom. I just wanted to follow up on Greg's comments regarding why not using IOM direct export with, compared to trace option type. A while ago, we were bringing a draft document into IPPM. We wanted to extend the direct export with having an additional timestamping field. And I think that shows clearly that not some of the features we have currently in IOM trace option type, we do not have them in direct export. And I think if the working group would align whenever we are solving the problem by moving some of the features we currently have in the trace option type into the direct export, I fully agree with Greg's assessment that this is solvable through IOM direct export. Thank you.
All right, thank you. That brings us to the end of our agenda, I think. All right, so we appreciate everyone who presented and commented and participated in today's meeting. Yeah, I think we have some action items going forward, hopefully moving along PDM, etc. Okay. Oh yes. Okay. Great. Okay. Fine. You got a couple minutes. Let's pull up your one slide and just give a quick intro. Thank you.
Just one slide. And okay.
Thank
Let
you.
me briefly introduce our work with some authors working in Huawei Cloud. That we propose in this draft customer experience index to evaluate network quality for cloud applications. And the scenario is that users will deploy their application in the cloud, and when the end user access the network, they will access their cloud application. They usually will proceed three network segments. That is access network, and in internet public network, and intra-cloud network. And now we can see that public network has the widest coverage always in the case, and it has high network complexity. So the quality of public network has great impact on cloud applications. And currently, we can find that all the cloud vendors, it's difficult to get directly access some application key quality index data. So they cannot clearly note the user application experience. So what we want to do is to propose a method from the perspective of cloud vendors and to discourage the application experience, and later they can make some network optimizations. So, and what cloud vendors can do is to derive the customer experience from some basic network KPIs like latency and packet loss and jitter, and such KPIs are accessible to them. And so the goal of this work is to propose a unified evaluating method of network experience for cloud applications. And we can see that currently no single KPI can provide accurate reflection of the experience for diverse service, because there could be some latency sensitive or some bandwidth sensitive applications, and they could fall into different categories and need different KPIs. And another challenge is that there is no unified evaluation method for some experience quality currently. And so we propose the method, and we observe from S-curve. S-curve is in this figure.
So if I could just, we're at the top here. So thank you for proposing this, and would urge people to take a look and engage with you. And just maybe one comment that you should maybe also take a look at one of the documents that we have adopted called Quality of Outcome. It seems like it has goals that align with your goals. So maybe it would be a nice thing to take a look at and discuss with those authors. Yeah.
Yes. Thank you.
Yep. Absolutely. All right. Thank you so much to everyone again, and we will see you on the list and next time. And please do check the list for our various adoption calls, last calls. We'll have some things coming up. Thank you all.
Definitely, it really reminds me of the QOO draft.